Welcome to another explainer. Listen, if you're gearing up for the Cambridge Computer Science 9618 exams, you already know the truth. Navigating past papers can honestly feel a lot like trying to survive a post-apocalyptic wasteland. It's brutal out there. Today, we're locking our focus onto one of the most treacherous, unavoidable territories in the entire syllabus: malware, viruses, and spyware. Now, to help us navigate this wasteland, let's look at two archetypical students. Maybe you'll recognize yourself in one of them. First, we have Alex. Now, Alex is a hard worker. Alex memorizes absolutely everything. But when it comes to the exam, Alex just dumps raw facts onto the page without any real analysis. It's just a wall of text. Then we have Sam. Sam is quick on their feet, but Sam rushes. Sam completely misses crucial command words and ends up answering questions the examiner never actually asked. We've got their flawed answers right here in front of us, covered in red ink. Today, we're going to figure out exactly how to survive this wasteland, fix these mistakes, and claim that A-star treasure. So here is the absolutely crucial question we need to ask right out of the gate. Why on earth do smart, prepared students lose marks on concepts they are already incredibly familiar with? I mean, you know what a virus is, right? You know what spyware does. It's not brand new information. Well, it almost always comes down to applying those known concepts to entirely unfamiliar contexts. You see, Cambridge doesn't just give you a blank line and say, hey, define a virus. No, they give you a complex, real-world scenario. They'll describe a global shipping company's logistics network, or maybe a highly secure hospital patient database, and then they'll ask you to evaluate the specific threats to that specific system. This is exactly where our student Alex suffers from raw fact overload. Alex just lists out dictionary definitions with zero context. The examiner doesn't care that you know the definition if you can't apply it to the hospital database. And Sam? Well, Sam just rushes in and completely misses command words like evaluate or compare. Listen to me on this. If you just list facts, or if you ignore the command word telling you how to answer, you are literally leaving massive, massive marks on the table. And this beautifully illustrates a trap that so many students fall into. It's the illusion of superficial breadth versus the absolute necessity of analytical depth. Let me be real with you. Cambridge examiners have made this crystal clear year after year. They do not want a laundry list of facts. They aren't looking for trivia. They heavily, heavily reward connected, conceptual understanding. So instead of wasting your time listing 10 different types of security threats and writing one sentence about each, you need to deeply analyze 2 or 3. You need to explain exactly how they exploit specific vulnerabilities and then evaluate the mitigation strategies. An A-star candidate doesn't just write, spyware steals data. That's superficial breadth. Instead, they provide analytical depth. They explain the causal relationship. They write something like, spyware infiltrates buying a Trojan payload, quietly logs keystrokes to capture administrative credentials, which directly leads to a catastrophic data breach. Do you see the difference there? Depth always wins over breadth, every single time. Okay, so how do we actually do this? Here is the exact blueprint we are going to use today to transform those red pen marks into green check marks. 1. Decoding malware core principles. 2. The method mark strategy. 3. Mastering critical analysis. And 4. The top 3 examiner warnings. Let's get moving. We're kicking things off with Section 1, Decoding Malware Core Principles. To really master this, we first need to break down the specific assessment objectives. These are the actual academic benchmarks the examiner uses to grade your paper. If you don't know the rules of the game, you can't win. Number 1, precise definitions. You can't be vague. You must mention, for example, that a virus requires an active host program to replicate, whereas a worm self-replicates independently across a network. That distinction is key. Number 2, causal relationships. Examiners want to see the chain of events. They want you to show your work. How exactly does the initial infection cause the final system failure? Walk them through it step by step. And number 3, this is the big one, cross-topic connections. Top-performing students don't view syllabus topics in isolation. They connect malware to other areas of computer science. If you can mention that spyware intercepts unencrypted packets over HTTP, but is effectively thwarted by transport layer security, or TLS, you are proven to the examiner that you understand the entire computer science ecosystem, not just one isolated chapter. But how do you actually structure all of that high-level thinking on the page? You need a structural foundation, and we call it the PEEL framework. That stands for point, evidence, explanation, and link. Let's break it down. Your point is your direct, punchy answer to the question. Your evidence is the specific technical detail you pull directly from the scenario they gave you. Your explanation is where you show the how and the why. And finally, your link ties it all back to the original question. Let's imagine a question about a corporate network facing malware threats. Your point, implement endpoint detection. Your evidence, the scenario states employees frequently download external files. Your explanation, the detection system uses behavioral analysis to proactively quarantine zero-day viruses before they can execute. Your link, therefore, this specifically mitigates the risks introduced by those employee downloading habits. Boom! That right there is a maximum mark paragraph. It leaves the examiner with absolutely no choice but to give you full credit. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's jump right into Section 2, the method mark strategy. Listen up, because this is the standardized 5-step processing sequence that Cambridge actually expects you to run through in your head. Step 1, identify elements. Ask yourself, what are the key variables in the scenario? Step 2, apply relevant principles. Which security concepts from the syllabus actually fit here? Step 3, execute analysis. This is where you write down your step-by-step logic. Step 4, verify results. Take a step back and ask, does this actually solve the prompt-specific problem? And finally, Step 5, present in the correct format with precise terminology. We worked with our student Alex on this. Once Alex stopped just dumping facts and started using this sequence, identifying a local area network, applying network firewalls against the malware, and executing a logical, step-by-step explanation of packet filtering, it was like magic. Those red pen marks immediately turned into green check marks. It's all about processing the information systematically. And this brings us to what is arguably the most critical examiner alert you will ever hear. Quote, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. I need you to really absorb this. Algorithmic thinking, which is the core of computer science, requires step-by-step decomposition. Think about it like this. If you design an algorithm to detect anomalous file sizes to catch a virus, and you mess up the very final loop condition, but you clearly defined your data structures and you correctly initialized your variables, you will still get the majority of the method marks. The examiner wants to reward your logical process, so please never leave a blank space and never ever jump straight to the final answer without showing the journey of how you got there. Your working out is your safety net. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome back. Let's dive straight into Section 3, Mastering Critical Analysis. This is where we put theory into practice. We're going to run a quick interactive workshop right now. Here is Challenge 1, the data scan. I want you to imagine a complex chart on your screen showing malware proliferation over a 6-month period following a major system update. Your task? Extract the core trend. You have 60 seconds on the clock in an exam scenario. Look closely at the data. What you'd notice is how spyware infections drop sharply right after the security patch, while polymorphic viruses remain totally stable. Now, to get top marks, you can't just list those two facts separately. You must use a comparative connective. You need to write something like this. Whereas the security update significantly reduced spyware vulnerabilities, it had a negligible effect on polymorphic viruses, indicating the patch addressed specific data logging exploits rather than file mutations. Do you see what we did there? We didn't just read the graph, we analyzed the relationship. That is exactly how you extract a core trend and secure top marks. All right, let's step right into Challenge 2, Find the Flaw. I'm going to read you a sample paragraph written by our student Sam, and I want you to spot exactly where things go wrong. Listen closely. The company should install an antivirus program. This will stop all threats to the computer and data security. Therefore, the network will be completely safe from hackers. Okay, did you spot the flaw? If you pointed right at the phrase, "this will stop all threats" or "completely safe," you absolutely nailed it. Top-scoring candidates always evaluate trade-offs, and they explicitly acknowledge limitations. An antivirus relies on signature databases, which means it is largely ineffective against brand-new zero-day exploits or social engineering attacks like phishing. You will lose major marks if you claim any single software solution is a perfect, impenetrable shield. In computer science, nothing is completely safe. Always demonstrate that you understand the limitations of the security measure you are proposing. Moving into our final, critical phase, Section 4. Top 3 examiner warnings. Pay close attention here. These are the specific traps that catch even the smartest, most prepared students year after year. Mistake number 1, confusing cause and effect. Remember, a virus replicating itself is the cause. The hard drive filling up, slowing down, and crashing is the effect. You have to keep your logical sequence straight, or the examiner will assume you don't understand the mechanism. Mistake number 2, ignoring boundary conditions and edge cases. Ask yourself, what happens to the security protocol if the network suddenly goes offline? What if a user inputs an entirely unexpected data type? Robust, A-star answers always account for edge cases. And mistake number 3, honestly, this is the biggest one of all. Answers lacking specific context. If the exam question is asking you about securing a maritime navigation computer on a cargo ship, and your answer talks about protecting the corporate office Wi-Fi, you will get 0 marks. Generic, one-size-fits-all answers are heavily, heavily penalized. You must tailor your knowledge to the specific scenario provided. Now, I know dealing with all these technical details and scenarios can feel incredibly overwhelming, so I want to give you a memory hack, the visual story method. During your revision, don't just stare at a textbook and try to memorize lines of text. Instead, visualize your computer network as a heavily fortified medieval castle. Let's build it out. A standard virus? That's a corrupted cart of grain brought inside the castle walls, slowly spoiling the rest of the food supply. Spyware? That's an invisible spy clinging to the shadows on the ceiling, silently watching the king enter the code to his vault. The network firewall? That is your massive wooden drawbridge, controlling exactly who comes in and out. And your antivirus software? That's the dedicated guard at the gate, checking every single visitor's ID badge against a known list of wanted criminals, which is your signature database. By encoding these complex, abstract computer science concepts into a vivid spatial story, you make them instantly accessible in your brain, even during the intense stress of the final exam. Let's pull everything together and recap the complete answering system. If you follow these 3 rules relentlessly, you are looking at 100% mark potential. First, command word decoding. You must aggressively deconstruct the question and extract the relevant scenario data. Know if you're evaluating, describing, or comparing. Second, the Peel application. Point, evidence, explanation, link. Execute your analysis with clear notation and highly structured paragraphs, so the examiner doesn't have to hunt for your brilliance. And third, the time management matrix. Present your answer with correct terminology, but allocate your time strictly based on the number of marks available. Please, do not spend 10 minutes writing a beautiful novel for a simple 2-mark definition question. Manage your time like a professional. Now, you might be asking, why do we push this specific system so hard? Well, the data doesn't lie. Our data shows that students who implement these exact strategies, systematically decoding the command words and rigorously using the Peel framework, improve their performance by an average of 2 full grade boundaries. Let that sink in. That is literally the difference between walking away with a C and celebrating an A. But here's the catch. You cannot just listen to this explainer once and expect magic. You have to actively apply the system to past papers over and over until it becomes pure second nature. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. To wrap up today's explainer session, I want you to really think about this. Cybersecurity isn't just about throwing money at software or building higher digital walls. It's about deeply understanding exactly how the attackers think, and then applying that logical analysis to protect your specific, unique environment. The Cambridge 9618 exam is designed to test exactly that. It's testing your ability to think like a dynamic, analytical security expert, not just someone reciting a textbook. So the very next time you sit down with a past paper, I want you to ask yourself, are you just dumping facts onto the page like Alex, or are you strategically, analytically securing the system? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep studying, stay structured, and I'll see you in the next explainer.